All right, here we are. We're subtracting mixed numbers where the denominator is different. And so step one, we have to find the LCM of both 5 and 4. And I think this time let's go ahead and do the chart method again. So I'm going to do 4 and 5. I always put the smallest number on top is what I do. And now I'm just going to list the multiples of 4. So 4 times 1 is 4, times 2 is 8, times 3 is 12, times 4 is 16, times 5 is 20. And of course, that's where we're going to end up. But let's go ahead and do the 5. So 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20. And ding, 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 there we go. Our LCM, the LCM of 4 and 5 is 20. Yay. Here we are again. We're going to go and make each denominator now equal to our LCM. The LCM again was 20. Oops, 20. And so we're going to do 3 and 2/5 times fraction equals fraction, and 1 and 3/4 times fraction equals fraction. And we know that the new denominator is 20, so I'll put that in here. And starting in the top, 5 times what is 20? Well, we just did it. It's 4. 4 in the denominator, 4 in the numerator. And now completing this, 2 times 4 is 8. So that's 8/20. And bring our whole number back into here, so we have 3 and 8/20. Now to the bottom, 4 times what equals 20? Well, of course it's 5. 5 in the denominator, 5 in the numerator. And completing, 3 times 5 is 15. And bring our 1 over. So now we've finished step 2. We made each fraction's denominator equal to the LCM. All right, so I've rewritten our problem with our new denominator being 20. And now it's time to subtract our numerators. And so this is the first way I'm going to show you. So here's the way we're going to do option 1. Option 1 is we're going to turn each of our mixed numbers into improper fractions. Okay, so how do we do that? So we'll start at the top number here, and we're going to go 20. So we take our denominator, 20, times 3. So 20 times 3 is 60. Okay, a little 60 up here. And then add our numerator, plus 8. So that gives us 68, and the denominator remains the same as 20. So 3 and 8/20 is equal to 68/20. All right, let's do the same thing down here. 20 times 1 is 20, plus 15, that gives us 35/20. And now, once we've turned these into improper fractions, okay, 68/20, take away 35/20, you notice we don't have to do any borrowing or regrouping. Now we can go ahead and just simply subtract our numerators. We know the denominator is going to be 20, so you can go ahead and put that down there. So come back up here. So we have 68, take away 35. So 8 take away 5 leaves me with 3. 6 take away 3 leaves me with 3. And now we are left with 33/20. So we're still in that first option there, where we end up, once we turned our mixed numbers into improper fractions, we were left with 33/20. And how do we simplify that? Well, we divide the denominator, 20, into the numerator, 33. And so 20 can't go into 3, but 20 can go into 33 one whole time. 20 times 1 is 20. We subtract 3, take away 0 is 3. 3 take away 2 is 1. And so what we're left with now is we have one whole number, so we have 1. And then the 13 is our new numerator, and the denominator remains the same, 1 and 13/20. Well, we may need to simplify our fraction again, just to be sure. So let's look. Okay, 13 is a prime number, so I know only 1 and 13 will divide into 13. And seeing 13 can't evenly divide into 20, we know we're done. And so the answer to this problem is 1 and 13/20. So as I said, this is one option. All right, we're going to take a look at another way of solving the exact same problem. Okay, so here is option 2. So you can try it this way as well if you like. This way here, same problem. We have 3 and 8/20, take away 1 and 15/20. And the first major problem is we can't take away 15 from 8. So in this case, just like we've done in other times in other years, we can borrow. So when we're borrowing, we're going to borrow from this whole number 3. Okay, so we're going to borrow from the 3. But always remember that this 3 represents how many denominators we have. That's 20. Remember what we did last time? We did 20 times 3, 60. So really what we're sitting here is this 3 really represents 60 total pieces, or 60 of something, or 3 groups of 20. So when we're borrowing, if I'm borrowing from this 3 and making this a 2, what I've really borrowed is 20 of something. And I already have 8 of that, so my new problem really is going to be 2. Okay, that's from what I borrowed. And then, see, now I'm borrowing 20, so that's going to give me 28 over 20. It's the same thing as what we did. Instead of having 3 wholes, we now have 2 whole numbers plus the value of the denominator. In this particular case, it's 20. So I added the 20 to the 8 and giving me 28. And now the bottom number, I don't need to do anything like that. I'm going to rewrite it over here. And now, as you can see, now I can go ahead and subtract the numbers as needed. So I have 8. Sorry, let me adjust this. I know my denominator is going to be 20. So if I have 28, take away 15. So 8 take away 5 leaves me with 3. 2 take away 1 leaves me with 1. And okay, so that's our fractional part. And now looking at the whole number, 2 take away 1 is 1, and that's how we do it. So now we have left, this last step is simplify if possible. So we're left with 1 and 13/20. And as we did before, we realized that 13 is a prime number and 13 cannot evenly divide into 20. So therefore, we know this is simplified. And now, this is 2 ways that you can subtract mixed numbers when the denominator is not the same. Step way 1, or option 1, was you can turn both of your mixed numbers into improper fractions and then subtract your numerators. In the end, you're probably going to need to simplify. In option 2, we borrowed from the top number, from that first whole number, and borrowed the denominator, the value of the denominator, and placed that value into the numerator, and then we were able to subtract as normal, and it turned out in this particular case we didn't have to simplify it in the end. But don't always assume that just because you use option 2 you won't have to simplify. But there's 2 ways of solving the same problem. I want you to get comfortable trying both. But right now, pick one of these that you feel most comfortable with and start practicing some of those with the problems that we do. I hope that helps, and that's another video for us. Thanks.